Until now, we have only used one instrumental variable, but you can use several instrumental variables. So for example, if your regression equation is as such, plus x, which is endogenous, and the instrumental variables are z, and the control variables are w, or exogenous variables, they are also w. This is supposed to be the regression error term. You can have more than one instrumental variable to control for or to extract the exogenous part from x. So what we get is the first stage regression, which is the endogenous variable explained by the instrumental variables plus the control variables and the exogenous variables. So these are all exogenous and control variables. And these are the instrumental variables. Okay, and from this you get the x hat, and these you can use in the ordinary regression. So for example, in this case you get not z, you're explaining the y equals the intercept plus the beta 1 times the x hat, right? And you have to remember the exogenous variables or and the control variables. Okay, so here in this second equation you have m plus r. Let's see, one, yeah, not m plus r. Let's see, we have to get this right. You have r exogenous, or let's say plus 1 exogenous variables, and this is u. So this first step is just to regress x on all the instrumental variables plus all exogenous and control variables to get the exogenous part of x, which is stored in x hat, and this x hat you use in the second stage regression along with all exogenous and control variables to explain y, and the parameter in or coefficient in interest is this one. Okay, you are interested in isolating the effect of a change in x on a change in y. Now that we have more than one instrumental variable, our relevance condition is a bit different. So we need that at least one of the instrumental variables has a non-zero coefficient, the pi, okay? Because you regress the x on the intercept plus pi 1 z plus pi 2 z2, right? And plus the w's, right? So at least one of these instrumental variables have to have some kind of explanatory power on the variation in the endogenous variable. If they don't, then only the exogenous or control variables has any explanatory power on x, and they are possibly perfectly multicollinear. And the second condition is the exogeneity condition. And here we need that all the instrumental variables are uncorrelated with the original population error term, the U.